Okay. Hi, welcome to HOM. So now today we will be going through how to factorize numbers in a topic called algebra. So here are some of the questions that we'll be doing together today. First question is to factorize 27n cubed minus 3n. And second question is to explain why 27n cubed minus 3n is divisible by 2 for any integer n. This question is contributed by AHS, Anglican High School, from the 2019 prelim paper 1. So I'll give you a few minutes to try this question out. Let me give them a few minutes. Okay. If you are stuck on this question, let me give you a hint. The hint is use a squared minus b squared equals to a plus b times a minus b. So I'll give you a few more minutes to work this question out. Okay, so now you have done this question, let us go through. So factorizing 27n cubed minus 3n, let me just write it down here. So what does it mean to factorize? It just means to break these terms, this expression down into simple parts that actually multiply to give you this. So 27n cubed minus 3n, one of the things that you can think of immediately on the top of your head is to take out the number 3. Because 3 times something gives you 27n cubed minus 3n. And that is given by 9n cubed minus n. So now I've taken out 3. What is another thing that you can take out? A lot of people will say it is n. So let's just take out 3. Let's just take out n. So after I take out n, you give me 9n squared minus 1. Okay, so now this question, do you think, can it still be factorized further? The answer is yes. And given this hint over here, we can actually still break this down further, 9n squared minus 1. Why can we break this down further? Because 9n squared is equals to 3n squared minus 1. And we can also put a square at the top of 1, because 1 squared is equals to 1. So from here, we can actually just try and match the formula together with the expression over here. Let a equals to 3n and b equals to 1. And this is how we can expand this 3n squared minus 1 squared to give us, so we're just going to plug this thing inside. So a plus b, so a is 3n, b is 1. And for the other side, a minus b is just 3n minus 1. And there you have it. This is the completely factorized version of 27n cubed minus 3n. Why is it completely factorized? Because there's nothing else you can do to 3n plus 1 and 3n minus 1. So this is our final answer. Now let's work on question part 2. Explain why 27n cubed minus 3n is divisible by 2 for any integer n. Okay? So given that this is part B, usually part A, you have done some work in in factorizing 27n cubed minus 3n. So now you're supposed to apply part A to part B. So how to do this is that 27n cubed minus 3n, we're going to show that it's divisible by 2. Why is the factorized form very useful for us? This is because you can see that the factorized form actually gives us all the roots, all the all the factors of 27n cubed minus 3n. which is what we want. If the factor is divisible by 2, then we can safely say, oh, okay, 27n cubed minus 3n is divisible by 2. So let's just try this out. So this is 3n times 3n minus 1 times 3n plus 1. Okay, so we want to show that this is divisible by 2. How do we show this? There's nothing that says, oh, this is divisible by 2. So 3n it may not be divisible by 2. It depends on what n is. So suppose if n is even, what happens if n is even? Well, because n is even, if n is even over here, because of this term n over here, that means if I can just divide it by 2 whenever I want. I don't really need to care about 3n plus 1 and 3n minus 1. So if n is even, so we don't need to do anything. Because n is even, this whole expression is even as well. Because of the n. Because it has a factor n. And because n is divisible by 2, that means 27n cubed minus 3n is divisible by 2. Okay, but this is only like half of the story. But there's also the second half of the story. If n is odd, then what will happen? So if n is odd, then we cannot use 3n because n is odd already. So let's say if n is odd, what can we, so what are the terms that we can still rely on? We can't rely on the 3n, so we can only rely on 3n plus 1 and 3n minus 1. But this actually says something about it, because if n is odd, so 3n is definitely odd, because odd times odd is an odd number. Okay, so that means 3n is odd as well. And given that 3n is odd, then even 3n is odd, then 3n plus 1 must be even. This means 3n plus 1 is even. Why? Because every odd number, the next number will be an even number, except for -1. So, so this means that 3n plus 1 is even, and therefore we prove that because so there's also one more number that is even, which is also 3n minus 1. So they are both even. And this means that given that these two are even, that means one of these can be divided by 2. Actually, both of them can be divided by 2. And if both of them can be divided by 2, that means the whole expression can be divided by 2. And that's how we are going to prove it. So if 3n is odd, this means that 3n plus 1 and 3n minus 1 are even. And since 3n minus 1 and 3n plus 1 is divisible by 2, that means that 27n cubed minus 3n is divisible by 2 as well, and therefore is even. Let me just write divisible by 2. Okay, which is even. Okay, so now we have proved this. So to recap, we have actually made use of a squared minus b squared to help us solve this question. And we need some clever manipulation over here, whereby we let a to be 3n and b equals to 1, so that we can actually break this down into a squared plus minus b squared, and we can actually subsequently get these terms out. Okay? So one follow-up question would be, what if I change my terms 27n cubed minus 3n to maybe 64n cubed minus 4n? Will you be able to solve this? Let us know in the comments below. Thank you. Okay, number 1 done.